In this video, I'll be talking about pressure. And what I mean when I say pressure is gas pressure. So the way to measure amount of gas is by using pressure. And well, pressure is simply, let me fix this. It's simply amount of force per unit area. So force over area. And we know that force is in newtons. The area is in meters squared. So this gives us a new unit. So newtons over meters squared, or you could say kilograms meters over meters squared, is simply a Pascal. Or you just write PA. However, there are more units for pressure that we'll use more often. Let's write all of them. So units. The one we use the most is called an atmosphere. So you just write it like 1 atm. And that will be equal to 760 millimeters of mercury. That is another unit of pressure. It's not. It doesn't mean it has to be mercury. But the unit is called millimeters of mercury. We can also say that 1 atmosphere is equal to 760 torr. Another unit we have is using the same 1 atmosphere is equal to 14,696 pounds per square inch, or just PSI. And I talked about the Pascal, so let's give a unit. I give it a conversion for that. So 1 atmosphere is equal to 101,325 pascals. Or you could just say 1 atmosphere is equal to 101.325 kilopascal. And there's one more unit that we call a bar. So 1 bar is equal to 10 to the 5th Pascal. So those are the units you'll use to measure pressure, but the most common one will be the atmosphere and sometimes the torr. But be sure to try and remember all of this. And the way to measure pressure is by using a barometer. So barometer measures pressure. However, there is another device that can measure the pressure of a gas sample, and that is what we call a manometer. And there will be, it could be an open-ended, or a closed manometer. We'll talk about each in the next page. Let's start talking about the simplest one, which are the closed manometers. And it'll be something like this. So you have your gas here, and this will be connected to a tube. It'll go like this, but this is closed. So this section is closed. So that means that the surroundings won't play any role in determining the pressure of your gas, because they can't go out. Now this gray thing I drew here is not your gas. Your gas will be the gas will be right here, and this gray column are millimeters of mercury. So the way it works is that the way you determine the gas pressure is that this gas right here will push the mercury and make it move like the gas will make it move, and the mercury will go up until like here, let's say. So that will create a difference in height that will be like, let's say, 770 millimeters of mercury. So let me write it here. And that is our height difference. So because there's no touch with the environment, the atmosphere won't play any role here. So you can just simply convert from millimeters of hydrogen of mercury into atmosphere or the desired unit. You would simply do this: 770 millimeters of mercury. We know that let's say we want an atmosphere. We know that 1 atmosphere is 760 millimeters of mercury. This goes with this, and we divide 770 over 760 to get 1.01 atmosphere. That is our gas pressure in a closed manometer. So now let's go to an open manometer. So open. Now this one is a little more complicated because you will have the same setup, but this part will be open. So you have to count the pressure exerted by the atmosphere in your calculations. We will still have like our same setup with the mercury here, but we'll have to count what gets in here. This will be your gas right here. And well, we'll have two cases. The first, if the pressure of the gas is less than the pressure of the atmosphere. And the second case is, well, if the pressure of the gas is higher than the pressure of the atmosphere. And we'll do problems for each of them. And just to not make this video too long, I'll attach the link for another video in which I do practice for both of this, so that you can understand it better. I just don't want to explain you the theory and not do any problem. So I think making a video just for it would make it better.